In a time when nobody cared about this, or especially this.
Oh no!
Anyways, to raise chemical awareness in a time of chemical persecution.
One team of 3 brave, dedicated, and strikingly handsome men have come together to fight the power of anti-chemicism. Bam! 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 To do so, they must educate the public via mass media, aka news outlets. However, because of the high risk behind this, they have to go underground and absolutely needed a hot tub.
This is their story.
Hello, ladies and gentlemen.
Dude, why aren't you wearing shirts? This is a newsroom.
Dude, it's a hot tub!
Oh, cut!
Alright guys, well, since I already have the floor, I'll start off the broadcast. So basically we have to do some general chemical and physical properties as would be, necessary in everything. Isn't that right, Tim?
Uh-huh.
Yeah.
I completely agree.
Okay, so general nitrogen group stuff. First off, you have 5 valence electrons. Then you have a wide variety of physical and chemical properties. This goes without saying, of course, right?
Right.
Right.
Well, of course.
Right.
So smart.
And then you got the elements themselves, which are relatively unreactive, but at times can be extremely reactive when they're in compounds, such as nitrogen, which at times can make things like TNT and nitroglycerin.
Boom!
So, alright, when you get into like what's a gas, what's not, nitrogen's the only gas, phosphorus and bismuth are the solids, and arsenic and antimony are the metals. Nitrogen is the first of like the main important ones in the nitrogen group. Obviously, I mean it's named after nitrogen. Nitrogen in its gas form is colorless, odorless, and relatively unreactive. Then you have phosphorus, which is the second most important in the nitrogen group, and it's a solid. There's 3 types, and solid. No. Well, it is a solid actually. It might not be solid.
And the thing about phosphorus is it's very in 2 forms. One form is white phosphorus. It's like really reactive.
Alright guys, today we're going to show you some of the uses for phosphorus. And to do that, we have Tin right here as our bomb squad fire technician in case anything goes wrong. And we have Patrick, who actually constructed the bomb itself. Take it away.
Right here, basically it's a grenade, potassium nitrate. It's to simulate the military grenade, the phosphorus M34. Basically all the white smoke you see, if it was phosphorus, would be on fire. But obviously we can't do that. But
and that's why he's our technician.
Yeah. Absolutely. Well, here it goes. Aww. Any minute now. Alright, get away. I think we should.
Two are commonly used. White phosphorus is the not commonly used form, and it's extremely reactive as it blows up upon contact with the air. However, the other 2 forms, black and red phosphorus, are relatively stable. And then finally, you have the third most important kind of group, or elements in the nitrogen group, which are arsenic, antimony, and bismuth. They're all solid, and antimony and arsenic are the 2 metalloids.
Dude, this nitrogen stuff is getting boring! Give me this! Sit down!
Alright, the oxygen group, the cool group.
Whatever.
Oxygen, gas. The other 2 that we have are sulfur and selenium, which are solids. Tellurium and polonium are also metalloids. Oxygen has 2 allotropes. Ozone, which is in the air, stops UV rays and heat from entering our atmosphere. Sulfur. It's a solid, it's usually found combined with other elements and such, and sulfur dioxide produces a really bad smell. And it also produces acid rain, which nobody really likes. Selenium is also a solid. It's purplish gray, kind of non-metal, and it comes in a crystal shape. It conducts electricity better in light than in dark. Kind of interesting, you know? Yeah,
I guess so.
All right.
So, Tim, what you doing there?
Making copies with selenium. Done. And here you go. Alright.
Periodic table placement.
Alright. Our elements are placed on the right side of the 6 and 5 column. This means it has 5 and 6 valence electrons. And it has a small atomic radius because it's located relatively on the right side. And anyway, it has high ionization energy because it's located far to the right and has high electronegativity. Yeah!
Periodic table placement. All right, guys. So now, to raise awareness about chemistry, we're getting to the third major topic we have to go over, which is reactivity. We'll start off with nitrogen. It's pretty reactive as it is diatomic. Remember the Coach Lyle word Brinkelhoff? The N is for nitrogen, and so it's really reactive. And so it's an N2 allotrope whenever it has to be in the oxygen or in the air that we breathe. Which also brings me to oxygen, which is the other 21%, as nitrogen is 78% of the air, and it's also diatomic as it's very reactive. For example, ozone, it actually it decomposes upon contact with heat or UV light. Phosphorus, you know what? That starts with a P. Why don't you take it, Patrick?
Dude, this is crap. What'd you do on it? Basically, phosphorus is, hey, camera on me. Here. Phosphorus has two allotropes. It's white phosphorus and red phosphorus. White phosphorus burns in contact with the air, so it's kind of, sort of, a lot of reactive. And then later on, red allotrope, red phosphorus, is the other solid, which is nicer, which we use on match. Talk about sulfur.
Oh, that smelly thing? Okay, when it burns in the air...
What do you do with stinky feet?
Okay, when it burns in the air, it reacts with the oxygen to form sulfur oxide, which produces acid rain when it mixes with water vapors.
Alright, guys. So, in conclusion, we're really happy we got to educate you as an audience, right? Great job.
Good job.
Honors. Kudos. Awesome.
Alright.
And so, we're really happy we got to do all this, and I hope we got to stop some of this rampant anti-Cometicism that's been going on lately. And so, for now, that's a wrap. Unscripted.
And we're out of here. Right. Let's go.
Get involved!
What?
What?
I
In a time when nobody cared about this.
You saw your finger.
In a time when nobody cared about this. Or especially...
That didn't work.